Okay, so first thing I'm going to just change is that little 20% needs to be a 25%. All right, so again, the challenge is to come up with our model. So let's think about what's happening. Our ball gets dropped from a height of 25 meters and it rebounds only 75% of the way. Yeah, so after the first bounce, it's going to rebound 25 times 0.75. Yeah, 3/4 of the way. So then it's going to fall down again. And from that height, it's only going to again rebound 3/4 of the way, or times another 0.75. And then after that bounce, it's going to rebound only another 3/4 of the way, or 0.75. So you can see that after one bounce, 0.75 times 25. After two bounces, 25 by 0.75 squared. After three bounces, 25 by 0.75 cubed. Which leads us to the height of the ball at any point in time is 25 by 0.75 to the n. Right, so I think that's the most challenging part. So now if we want to do a quick graph, well, we've got an exponential graph. The height of the ball at the start is at 25 meters. And as it goes on, okay, as the number of bounces increase, the height is decreasing. So we've got a decreasing exponential graph. And so if we just pick another random point, okay, just to label it, just to give you an idea of where we're at, okay, so it goes through the point 10, 1.4. I hope that point's still right, to be honest, because I made some changes. Anyway, we'll think about that. All right, so we've got our graph. Find the height of the ball after 4 bounces. So at n equal to 4, substitute n equal to 4 into the equation. I get 7.91 meters, which to the nearest centimeter was 791 centimeters. All right. Find out how many bounces are required for the ball to rebound at less than 35 centimeters, which is 0.35. So I want to solve where h of n is less than 0.35, or where it's first equal to 0.35 in reality. And what we're saying is that it first becomes less than 35 centimeters after 14.8 bounces. Now, it doesn't matter where that point is. If we want it to come up less than 35 centimeters, it's got to be at least 15 bounces. So even if it was 14.1, we would need to round it up to 15 bounces, because it will take 15 bounces for it to first rebound less than 35 centimeters. All right. So if we check those answers on our CAS, you can just see there, if we substitute those values in, solve it on your CAS, and we see there that n has to be greater than 14.8, which means we're going to need 15 bounces. All right.